Hi everyone, my name is Olufemi Victor from Nigeria, and this will be my pitch presentation on AI Intuition Retrieval Augmented Generation for Public Services and Administration task. We're tasked with the responsibility of coming up with an advanced RAG system for public services to actually leverage on and make the most of their day-to-day task. So I'll walk you through a quick demo of my RAG as well as share my thoughts on further improvements. So this is a workflow of my RAG system. And what I was able to do was to chunk the entire Word PDF documents and then do some intensive cleaning and chunking strategies, and then use an embedding model from the Alibaba NLP, which is called the GT Large, to then create my vector database. So when a question is asked from the user, I then search the vector database and use that to retrieve the top 20 chunks. I then leverage on another model, which is called the BGE Ranker from the Beijing Academy Institute of AI, and then use that to re-rank and take the most relevant 5 chunks from the text. All right. So what are the key advantages of the solution I've built over the conventional RAG? One of them is, of course, the utilization of both lightweight and robust models. So I had to do a strategic choice of model selection, and of course, on the MTEB leaderboard, I leveraged on the GT Large specifically for its small size and yet maximum efficiency. So it's about 12 times much more smaller compared to other models of the same performance. And of course, the re-ranking model as well is also a lightweight small model, achieving similarly high results on both the re-ranking performance leaderboard. So of course, this model choice was to ensure both superior performance in the similarity search results and of course accuracy compared to other models, yet maintaining that lightweight nature so that we can leverage smaller computes. And of course, as well, I leveraged a more unique chunking strategy instead of the conventional fixed size chunking, where you just chunk up and overlap text. Rather, I then use a recursive character text splitter, where I leverage on custom separators such as conventional separators, including paragraphs, double lines, and much more. And then I also use a dynamic size chunking, which helps me to essentially maintain coherence and, of course, maintain the context of information within the chunks, which I found was very crucial for accurate retrieval. More so also, my solution also leverages the CPU alone. There's no need for GPU in both the building and use of the solution. So it's designed to run fully locally without the need of an internet or a GPU. And of course, this is important for sensitive data and to maintain privacy. One last thing is that the solution uses fully open source tools. So it was built on several tools. Among them is the LangChain, of course, models from the Hugging Face Hub, which were downloaded locally, and of course, ChromaDB, among others, which of course allows me to then reproduce my results as well as reduce cost. All right, but let me dive into some of the key weaknesses and challenges of this solution. One of them is that there was no fine-tuning in this solution. So while that made it, faster to build and much more easy to leverage on, the solution does not include, fine-tuning of the embedding models on domain-specific data. So of course, this could inherently limit, its effectiveness compared to a fine-tuned and specialized model in a specific public domain. One more is that as the number of files increases in order of thousands, you then would spend much more time on a CPU compute as regards to a GPU compute. While this runs fantastically well on a CPU, as you increase in order of magnitudes the number of files needed, there'll be a need to augment for the speed. Right. But what are some of my personal visions for improving this solution and to production grade and empowering the public sector? One of them includes enhancing performance and scalability. And as I've talked about hardware acceleration earlier, we would need to utilize hardware accelerators if we'll be handling large data sets as well as numerous or concurrent users. But if it will be deployed, solo, that is on a specific user's PC, of course, this can then be done on the CPU. Also, domain-specific fine-tuning is also quite important. So in as much as we even have the public sector domain, within the public sectors, we still have several, domains within the public sector. So it is then important to actually fine-tune models within these specific domains to improve both, the relevance of the accuracy of retrieved information, as well as, use adaptive pre-processing techniques to handle different, file structures. And this could include images, tabular data, and several other, structures that would need to be intelligently handled within the context. And much more than just building the AI solution, it is important to build a good and user-friendly interface, as non-technical personnel may as well be leveraging the solution, and this will make it easier for them to actually use the tool comfortably. And also, another insight, which of course was even drawn from the AI for Good summit, is to also provide training and support. Because deploying a solution is much more than just coming up with a solution. But of course, there's a need to actually go further to actually train the civil service, which you will need to actually use these tools. So I would say offer training and support, as well as developing a detailed documentation, tutorial, and other best practices to use the solution effectively and comfortably. And yes, and that brings me to the end. I hope you found this insightful. Thank you so much. Goodbye.